Alright, so here we have a table that records a car's position in feet at time t in seconds. So we want to find average velocity. Velocity is distance divided by time. So the average velocity over the time interval from 1 to 3. Okay, so from 1 to 3, the average velocity would be the change in position. That would be the distance over the change in time. So it'd be 40.7 minus 3.2, that's the change in distance, over 3 minus 1, which is the change in time. So that is 37.5 divided by 2, which would be 18.75. And for units, that we got units of feet on top, we got seconds on the bottom, so that would be feet per second. Okay. Over the interval from 2 to 3, same deal. The average velocity is going to be the change in position over the change in time. So it's going to be 40.7 minus 15.8 over 3 minus 2. Which is 24.9 over 1. So that's 24.9 feet per second. Over the next time interval from 3 to 4, same deal. Average velocity is going to be the change in position over the change in time over this time interval here. So that's going to be 72.0 minus 40.7 over 4 minus 3. So that's 31.3 over 1. So that's 31.3 feet per second. And then over the interval from 3 to 5, the average velocity, we're just looking, from, between, t equals 5 and t equals 3. So it'd be 110.8 minus 40.7 on top over 5 minus 3 on the bottom. So that's 70.1 over 2, which is 35.05. And again, that's feet per second. All right, for number 2, it says to use the graph of s as a function of t to estimate the instantaneous velocity at time t equals 3. So I would do this graph on a calculator here. I would enter those points into the stat menu. So you hit stat, edit, you put all your ordered pairs in there. You get a window, your x and y window, so that you can see all those points. Remember to turn the stat plot on, so second stat plot, make sure that first plot is on there. And if you graph, there are the points. Okay, so actually I'm going to put that in here so I can draw on it. Okay, so there's what the graph looks like. Now, here's where t is 3. That's the point that we're trying to find the instantaneous velocity. Now, what we found a couple of average velocities. We found an average velocity between 2 and 3 to be 24.9. So essentially what that means is that that's the slope. If we just connected these 2 points here, that slope is 24.9. That's what that average velocity calculation says. If we were to connect the t equals 3 and t equals 4 points, these points right here, that's got a slightly higher slope according to the to what we did over here. That slope is 31.3. Okay, the instantaneous velocity would be like if we were to draw, if we were if we were to connect the dots of the smooth curve, what would the slope of the tangent line be? And you can see that this graph is curving upwards here. The slopes are steadily increasing, and so the instantaneous velocity at 3 is going to be somewhere in between these two. Now it's hard to really get a good estimate, but one thing that one thing you could always do, you could just average those two slopes, right? If you know the slope is somewhere in between these two, you could certainly average them, and that's going to give you a pretty good estimate. So the instantaneous velocity at t equals 3, I could say a pretty good estimate would be the average of 24.9 and 31.3. Okay, if we had more data points that were closer to 3, we would use those values, but these are the closest that we have, so that's what we do. Now the average of those two, if I add them up and divide by 2, the average of those two is 28.1. feet per second. So that's what I'm going to use as my estimate for the instantaneous velocity at t equals 3. If you've got average velocities on either side that are relatively close, with points that are relatively close, averaging those two is will give you a pretty good idea of the instantaneous velocity at that point.